All right. Well, thank you all for being here again, and Shir for joining us on the stage. And I'm excited to kick off this discussion today where we'll go into a little bit more of moving from intent to impact, that bridging that performance gap, as Alit said, between design, between operations, and how each of you guys are doing that at your respective industries, a little more informally than how you've shared that so far. So I want to start off with you, Colin. You spoke a bit about how you bring into the ideas as early as possible in your process. So I want to hear what the ideal sustainability journey will look like for a design project, one that might be interested in sustainability or not interested in sustainability. Where in the process can those decisions have the most impact, and how does it look like in an ideal scenario?
I recall when I first started 22 years ago in this industry, it was great when we were involved in schematic design, right? And now I'm pushing things towards the very first day of conceptual design. And even before that, I even now request that we get involved in marketing, because we move so fast in the industry. We show designs to clients within a week. And I think it's quite irresponsible to show a completed design and a rendering to a client that quickly until you've done a shoebox energy model, until you've done the research on what's possible. So we typically try to get our mechanical engineers and our design teams doing that shoebox energy modeling day one of conceptual design. And people always push back and they say, well, we don't know what all the program space is quite yet. We don't know what the details are, and that's unfortunate. But we're using this information to inform design. It's data to inform design, and you have to do that modeling day one of a project, and that includes talking to the mechanical engineers and saying, like I said in my presentation, how would you design this space? Ask the civil engineer, the structural engineer, how would you design this space? It's unfortunate, and this was in Diego's slides too, when you see that big architecture bubble up front and all the work is done and then all the other consultants come on board and then you have to backtrack. And it's an inefficient way to do business, I think, and it's a poor design process. So day one concept or day one marketing.
Sounds exciting. I hope we get to try that out a few times. So then basically, Shir, I kind of want to hear on your side, as a client within Azrieli Group, a client on our side as consultants, but in Azrieli Group, how do you set those standards, and what maybe changes and innovations have you made over time that help you determine as developer, basically, what you require and ask from your clients, and how you kind of check whether they've met those requirements?
So thank you, Laurel, for the question, and thank you for this interesting session and this so important conference that you're doing even today, which is not obvious. So the first thing we do, that we embed our goals, our carbon goals, our EUI and embodied carbon goals in the design process from the beginning, which is not an easy thing to do. If you are familiar with the design process in Israel. So we do this session in the beginning when we discuss these goals with the teams, and we are not imposing, we are not imposing these goals like top down. We are building these goals together with our team. So as Alit mentioned in her talk, we have built this goal together with our internal design team, with our engineers and with our architect, and we are checking these goals all the time on our project. So we are learning from project to project. So we are trying this strategy in one project, and then we know if it fits to another project, and then we have this set of strategies that we can fit from and try from one project to another. So it's an ongoing learning process, and we adjust our goals after we try them in our project, after we know and we're familiar with all the challenges in embedding them in the project. So we have realistic goals at the beginning, and we are learning from the design process from project to project. And this is what the main theme.
Sorry, we need maybe get another mic if we can. But okay, so that was very interesting, Shir. Thank you. I'm glad to hear about the implementation. We do see that, working with you guys in the design process of how we were working and communicating with us in terms of adjusting those goals over time. And I know we spoke about creating more tools to bridge that performance gap. So on that note, I wanted to ask you, Alit, about that kind of relationship. I know maybe in the not too distant past, we spoke about getting the building as a surprise box present from the design side and say, okay, now let me figure out where I'm going to put the garbage cans or how I'm going to run this or how this interacts with that. So how at Azrieli have you guys been over time making those changes and opening those communication channels, and what kind of changes has it led to in the design of the projects that have helped the operations team?
So first of all, I want to tell you a story from the place that I'm living. I'm not going to tell you this because some of the people will. But when my oldest son, that is in the army right now, entered his first grade, he entered the first green school in Israel, which was planned, and it was amazingly planned, with the light all over and really nice, but actually nobody stuck with the maintenance team and with the education team. And after 5 years, when I was working in the environmental department and we tested that school, so we find out that this school is the worst school as far as efficiency per student, because this is the way that they measure it in Israel. So to build a green building is great and it's so important, but you have to work with the team on ground, and we keep saying that, and you have to put them into the planning process, because otherwise there's a lot of stuff that you don't see. So right now, in example, in Azrieli, Shir and I working together with the teams that are planning our buildings. I'm working with the teams on what is the journey of the waste. It sounds, everybody have a waste consultant and stuff like that, but you have to do the journey of the waste to understand how many workers you need on ground. The CapEx is quite easy for most of the real estate companies, but the OpEx, how many people you need to work, and everything like that, is going through gas emissions in the end of the day. So we're trying right now to get the operation team and engineering team working together, and the spiral that's going to be open hopefully in 2028, right? 2028, 2027. So already now, the operation team actually going through all the systems and all the maintenance stuff to see if that's aligned with our operation and what we can do about it and what we can change right now already in the spiral in order to operate this building in a much more efficient and the right way.
Can you give any practical examples of things that did change maybe in the spiral project that you looked at something and said, okay, that should be different, and then what it did look like? Like any specific system or anything like that?
I can. It's problematic, but I can give you on the waste, for example. The waste system in the spiral going to be one in a kind in Israel. It's going to be shots that go into pneumatic system, which is really, it's a high-rise, very difficult to plan, and hopefully it will work well. We have a separation in the region for 8 streams of waste. So we figured out that the the chutes have to be with the electronic devices in order for us to, it wasn't like that, it wasn't planned in the beginning. And the way that you clean the chutes. And so we implemented already stuff that wasn't planned in the beginning. And we taken under consideration what is the ROI of these systems, right? You have to stand in that. It's not always about the ROI, but it's the operation in the long term, which I think we don't have enough good tools right now to assess and to evaluate what are the OPEX cost will be in the end of the day. And I think this is one very important tool that I think all of us would be glad to have. Shir, do you have any more?
Yeah, maybe I can tell about the process we had on the facade with the spiral tower. So I don't know if any one of you knowing the presentation of the spiral, the admayot, the renderings, yes, the spirals, and it's the fins, the fins that go outside and shading the buildings. So those fins weren't in the building in the beginning design, in the initial design. They were added after the energy modeling that you guys did for us. And the architect Moshe Tzur, he added them and he designed them especially for the energy to block the sun radiation from entering the building in specific angles, and from the analysis that you did for us. So this is an example for a design team and a design theme and an image that was created from an energy modeling and from us wanting to improve the energy of the building. Yeah.
Great, thank you for those insights. Very interesting to hear on both sides, kind of how that actually affected the design. And Diego, I want to take it to you a little bit from a different perspective. You've shared with us that WSP has taken on to decarbonizing their operations as an organization. So I want to hear a bit more about insights from that. How did you guys look at your operations, maybe your facilities, and then what insights did you take and what changes maybe did you make as an internal organization? I know you spoke about the impact on the clients, but I'd like to hear more about the impact of the organization.
I mean, like many organizations, we have ESG commitments, and we wanted to reduce the carbon emissions. And we have an ambition. I think it's to become net zero. I don't know the exact year, but it's fine. And we faced a dilemma. 3 years ago, the lease in our building, our headquarters in London, it came to an end. We don't own the building. We have 500 people working there. And when we analyzed our energy consumption, you know, the EUI was around 220 kilowatts hour per square meter per year, 220. And in our plans to decarbonize, we had to reduce that to 70. So we said to our landlord, we love this building. We've been here for 15, 20 years, but we can't come back. What are we going to do? And then on the other hand, we've been advising so many of our clients to decarbonize and to reduce energy. So we said, this is the right opportunity to implement all of those ideas and strategies into our own building. So we agreed with our landlord that we wanted to design an office refurbishment. Now in the UK, reusing existing buildings is a market that has grown by 4 times in the last 5 years. We realized that to achieve the decarbonization for our clients, we and achieve that commitment of reducing the carbon emissions from our own design. If your business is growing and you design more buildings, how do you decarbonize more? One of the things we had to do was do more refurbishments, reuse existing buildings. So if you walk around Europe now in the UK, there's so much work on existing buildings. And I'll go back to our own building, but it is something that is happening not just in Europe, it is happening all across the Middle East. 3 years ago, I spoke to our team in Dubai, and they realized we have hundreds of towers, hundreds that were built in the 90s and the noughties. They are 20, getting to 30 years of age, so they will need to be upgraded. Their building services, their facades. So they are not historical buildings like we have in the UK, but they are existing buildings. And that is the most important thing that we can do. Our team here in Israel as well is looking exactly as that. You have the same challenge of reusing some of the buildings that were built in the 90s, in the noughties, or 10 years ago, because things are changing so much. So we saw that opportunity, and we said to our landlord, let's split the cost. Allow us to design our own building, and we'll help with the cost of the construction, so that we get to stay here and you get a better building. And it was so much pressure actually, because we had to really deliver on what we were promising to all of our clients. And we managed to reduce the energy intensity by 75%. Luckily, in the UK, the air outside is at 18 degrees most of the year. So we bring it directly from the outside, and we don't have to cool it too much most of the year. That reduces energy drastically, very quickly. But it also improves the quality of the air inside. It's not as dry because there's not so much air conditioning. It's so quiet that we actually had to install fake white noise of air conditioning, because otherwise it just feels strange if you don't hear that noise. So we brought our design team onto that journey, and now we take all of our clients to our office and we show them this is what you can achieve, but it needs a combined effort from clients, designers, the industry, and everyone. But it's been so amazing.
And then to take it back to you again, Diego, can you share some of the solutions that you're looking at, maybe particularly in a warm climate like Dubai, when you're taking an existing glass facade tower and you're looking at refurbishment? Where do you look first? How do you start? Can you apply maybe some of the tools that you showed us this morning to a project like that? And where do you take those decisions in terms of what implementations to actually do on a project like that? What solutions are out there that maybe we should think about bringing to Israel to be prepared to refurbish those buildings in the near future?
I think the near future is actually already happening. So we have recommended some of these ideas to the Azrieli plan. We have other clients that I can't mention that confidentially, but they are looking in Tel Aviv to be the first building that is optimized using this technology from an early stage. So we're super excited to bring all of that automation piece to that. To the one tower, want to be the zero energy tower, which is absolutely fantastic. So it is happening already. It's not in the near future. It's happening right now, and it depends on the climate. But the most obvious thing is the sun and shade. Treating the facade, each side of the facade, to respond to that, to minimize exposure to sun in the summer, but also to harvest that sun energy in the winter, because you might get that to improve your cooling loads. The envelope is, as Colin mentioned that in his presentation fantastically, trying to address the envelope is fundamental. We have a concept in passive house design, which is fabric first, fabric as in envelope first. That is the first thing that you look at. And from that, after you've reduced all of that sun exposure, then you look at the low carbon systems. For example, in the UK, what we have in our offices, we now instead of bringing air from the top of the building, cooling it and distributing that through these ceiling units, we bring the air at every floor. There's a mechanical room right next to the facade, which is controversial in some buildings, but when you think about an office building that has different tenants, there are divisions, you can introduce those. So we have a mini plant room in every floor, extracting air from the outside at every floor, which reduces the number of ducts and the embodied carbon of the building services strategy. And we do the small cooling that's needed in the UK, or the larger cooling that is needed in the Middle East in each floor. And that liberates space at the top of the building, on the roof, to do something nicer, like rooftop gardens or something else, change that use and give that back to the community, to the client, etc. So that is a fundamental change that we're seeing in buildings in the UK. Is on-floor plant rooms and ventilation systems, resulting from an extensive treatment to the facade.
Colin, do you have anything to add to that in terms of implementations that you've seen?
I think Diego covered it all. That was perfect. I mean, every climate is different. Obviously, you guys want to focus on hot climates. Existing buildings are a lot tougher than new construction. Everything I showed was new construction, and you can get to net zero pretty easily. But existing buildings, you're going to squeeze. I mean, 75% is amazing, but that's in the UK climate. We're lucky if we get to 55, 60 in some existing building retrofits. I will say again, the whole focus of the envelope. Whenever you do payback analysis for any envelope upgrade, I think I saw some of your payback analyses for solar shading and just did not have the payback. make sure you price the envelope upgrades with your HVAC upgrades together. They have to work in tandem. You can't do one alone. The payback will never be there. More insulation, more shading on its own, the payback won't work. It has to be a holistic pricing. So I just want to reiterate that point. So.
Good, thank you. Thank you for those insights. And now we'll take a few questions from the crowd before we finish and enjoy our lunch, and then we'll continue to more sessions later on. So the first question is around embodied carbon specifically. We talked a bit about improving the operational carbon and some strategies and examples. So maybe, the three of you are more in design, but Alit, maybe if you have any insights into renovations, I'm not sure, Shir or Alit, but sort of speak to some examples of ways in reducing embodied carbon. Timber here, unfortunately, isn't as a strategy we have yet in the market. So what kind of strategies do you see in practice?
Okay. So embodied carbon is a very hard challenge to tackle because we have two kinds of main actions that we can do. We have one actions that link direct to the way the building is designed, the distance between the columns and all the structure engineering and everything. And then you need to really introduce those goals to the teams ahead of time, and you have to design the building and the conceptual design when you're thinking on those goals. And these goals are this strategy is very hard to achieve, and you have all those different agendas in the design process. You have the architect agendas, you have the business department agendas, and you have the carbon agenda. So all of those things need to combine to work together. So it's very hard, and we have all those other strategies that we have, which are linked to the materials. And these are strategies we find more simpler to implement in our building, and that's what we did also in the spiral building, when we took all the facade, all the aluminum facade, and we used recycled aluminum. And this reduced our emissions in 36% for all the building. Because recycled aluminium is 86% less emissions than new aluminum. So we try to do that, and we are also asking from in our tenders from our constructors to use more recycled content in all the elements in the buildings.
I mean, embodied carbon is what I do, and I've been doing that for so many years now. And when we started the embodied carbon conversation in the UK like 5 years ago, that was my question as well. How am I going to do this? How? And then we realized that the first step to decarbonization, as Colin said, is reduce. And it's not just about reduce energy intensity, reduce solar exposure. It's reduce the amount of material that you use. They say the most sustainable building is the one that already exists. So the first step is reuse your existing building if you have one. The second one is reuse whatever you have on site. Extend the building if needed. Create extra floors with the same footprint. And then the next one is design efficiently to reduce the amount of materials that you use. And once you have achieved all of that, then you focus on the carbon emissions of the materials themselves. And in the last 5 years, and in my experience and the experience of my local team here in Israel, we have seen so many opportunities to reduce materials, the amount of concrete. The engineering is the same, the science is the same, the physics are the same, the equations are the same, the code is a little bit different, plus minus 3, 4, 5% here and there. The shelters, they are important, but if they're put in the right place, they help with other aspects of stability. So those differences are very, very small. What happens is the assumptions that you begin with, and that is the most challenging thing to change. Assumptions such as column spacing, Assumptions such as the distance between the facade and the building core. Assumptions such as the loads that you apply into a building. And historically, every country does different assumptions. And changing that mindset is the most difficult thing. But when you look at the interventions that you need to make, for example, a concrete slab from 30 centimeters to 25 centimeters, just that, it might need a slight movement onto the columns, a little bit here and there, and you made your building 25% less concrete. And that is, your handprint there is the greatest contribution you could possibly make. It makes the column smaller, the walls smaller, the foundation smaller, the basement smaller, everything is smaller. And 25% saving in concrete is also a lot of money. So it just makes so much sense to use less materials. It is the simplest, the cheapest, the most economical thing to do. All we need to look at is what assumptions are leading to those results and try to address that. And it doesn't mean put a column in the center. It just means maybe shifting the columns ever so slightly and finding that fine-tuning. That's it, I think.
Just one remark, because Diego was presented yesterday to our chairwoman, Dana Azrieli. And well, I think a good strategy to tackle that is we took really the team who did a great job here in the WSP, and they put all our buildings, the new existing buildings, and some of the planned building together, and they show where is the embodied carbons lay in each one of them, of the typology. And that created a huge change in the mindset of Dana and the team. Just to see it all together, which building have lots of slabs, which building have, more basements, and that created a shift in the mindset of our decision makers, and I think that was a very good approach.
Should I finish up?
One more question after this.
Oh, okay.
Yeah,
okay, so Diego's going to like this because I think your structural engineer should be an early designer on the project. Just like I said, have the mechanical engineer design the space, have the structural engineer design the space initially with you. We've seen 20-30% reduction in just laying the building out smarter, right? The complexities of initial layouts are not vet with structural engineers. So lay out the building smarter. If you can't do mass timber, obviously fly ash slag can get you to a 25-30% reduction in the concrete alone, which is helpful. But one thing I would note from doing a lot of EPDs in the past 5 years is there was this perception that using regional materials had a lower embodied carbon content, but that is not necessarily true. I would rather ship something over from Europe that was made on more renewable energy in the production process than buy something in the States that was built and manufactured off of a coal power plant. It actually has lower embodied carbon content. So look into your EPDs, and I think it's okay to source things from abroad as long as everything's manufactured on a clean grid. So dig into those EPDs early.
Very interesting. Thank you. Yeah, those are some assumptions we're going to have to work on now that we have more data and more EPDs, also specifically for local materials. We can start to make those apple-to-apple comparisons and take those decisions. And also just after lunch, we're going to be discussing a bit about implementing recycled content into concrete, what we can do with, perhaps buildings that were knocked down one way or the other recently, and how maybe that could be integrated into the system here. So that'll be interesting to continue that conversation around embodied carbon. The last question we have from the audience is about making future-ready buildings, that things are changing so fast. And the question is, if the buildings that we design using the data analysis and decision-making tools we have now will be relevant in 10 years, is it more crucial to adapt strategies and develop more adaptive materials, considering the fundamental unit of our buildings that will allow them to adjust to the future environmental and physical conditions in the urban fabric? Anything about, materials adjusting over time or adaptability and resilience? Anyone want to take that?
I can start. I'll start with something that someone once told me, and they said, if you want to meet someone that can predict the future, like a fortune teller, find an architect or a developer that is designing a tall building, because you have to predict what this product needs to be when it's finished, which is at least 5 years from now. And the market is changing so quickly around it, and you're competing against smaller buildings who will be in the market before you. So how do you anticipate that? And one of the tallest buildings that I worked on in London, it was built it was designed in 2015, and then it was built through COVID. And we had to respond and adapt so that we could anticipate that market trend of people working from home and people wanting to use offices differently. It led to something positive because occupancy in buildings reduced, so you had less energy, and it was brilliant. But anticipating that is a real challenge. If on top of that you think about climate changes and how wind loads are going to be different, how rain is going to change, how toxicity is changing, and how the amount of heat is changing, you have to be able to predict that and incorporate that. But it shouldn't be something that we're too scared about, because we can, if we make the decisions now to allow for flexibility, you can incorporate that. And the word that I like using, because it's so obvious, is when you think about structures, it's more obvious than when you think about anything else. And I'll give you an example. It's not flexibility, it's retrofitability. So I could design a building that is flexible because I don't know if it's going to be an office, a lab, or something else, and I've got 20 stories, and I could add all of that into the design, and that's going to make my building twice as heavy, twice as expensive, but it's flexible. Or I can make the decisions now to enable those retrofits or additional elements in the future. And that is, you have that future flexibility if you ever need it, if you ever want it, and then it's cheaper. And more importantly, because we are in a sustainability conference, you don't spend those carbon emissions now. You spend them in 20 years when it's needed. So there's a fine balance between what you call the environmental capex. What do you do now to allow for that flexibility? Or how do we anticipate what could possibly happen to the building so that we can incorporate retrofitability when, if needed?
One of the biggest things that we focus on for materiality, we're lucky enough to have climate scientists in-house, and so we usually ask them for 50 to 100-year weather files to put into our energy models. So our mechanical engineers grab those, and then we look at not only the future operational requirements for HVAC systems, but also the dew point. The dew point is changing for the majority of our projects. And if we design a building with the improper dew point, that entire facade and insulation is going to mold out and mildew out, and they're going to have to rip everything out. And so we're very cognizant of future weather files and grabbing that information from our resiliency team, because it'd be such a waste of embodied carbon and money to just rip out the whole facade in 10, 15 years. So that's one of the things we focus on the most at the moment.
So thank you very much for that really insightful discussion and interesting exploration into all of your different perspectives and the ways that we can do more. We're hopeful and optimistic that we'll implement everything discussed today and have more successes to share shortly. So thank you everyone for joining us on this journey. We'll continue with our lunch and meet here after at 1:15. Thank you.